Okay, so today we will discuss about the classified past papers of chapter number 7, that is the atmosphere and the human activities. So we will see the first question here. In the first question, they're saying that the graph shows the production of chlorofluorocarbons between 1950 and 2010. So here is the graph. You can see it is starting at 1950, and then every 10 years difference they have given here, and it goes, the last thing is 2010. If you see the graph, this is, this side of graph, this is the production. And how much production? 1,000 ton. It means that the, this is 2,000 ton, 200,000 ton, this is 400,000 ton, and this is 600,000 ton, the production of chlorofluorocarbon, CFCs. So if you see from here, in the beginning it's increasing, and then here increase is rapid because the line become more steeper. You can see here this area. And then if you go to this in the mid of 70 and 80, just like 19, you can say 71, 72, 73, 74. In 1974, you can see there is a decline, and up to 1975 here. Then again there is an increase, then again there is a decrease little bit, and then again rapid increase. But if you see from this point, in other word, you can say this one here, this is what will be, it is just like 1987, because it's 85, 86, 87. From here it start to decrease, and there's a rapid decrease, you can see here. Then this is a decrease, but in a slow. So this is the whole graph is described in this way. So here when you are describing this one, so you can take the number values. For example, you can say that in 1950 how much it was, let's say here. So you can say this is 200 each one, so it means 40. This you can say 40,000 tons. And then you can say in 1974 it was, you can see how much here, 900 ton, like this. So you can put the values also. So if you put the values, it's better. First of all, you can say that there is a increase up to, you can say 1960, but it's a slow increase. But after that there's a rapid increase, then again this is little bit decrease, then again slow increase, then there is rapid decrease, like this. So this is how you represent a graph, or how you describe a graph. So see the first question. They're saying describe the trends in the production of chlorofluorocarbon between 1950 to 2010. So here, as I discussed with you, you can, by this one, you can say increase from 1950, and how much it was, 400,000 tons. And in 1974, how much to become, 920,000 tons. And then from 1950 to 1958, the increase was slow, but the increased production. And here, so you can write anything from these three, you can write any one of them. These are the same thing. One thing, first thing, you can say that there is a increase, and you can use the numbers and values. 1950, this is how much, and 74, how much. And you can also mention slow in increase. You can say there's an increase, but in the slow. And you can say increase rate of production 1950 to 78. So it's up to you how you can do this one. After that, they're saying 1970 to 1982, it is just like on the level, you can say not increasing that much. But 1982, and it is increase here, how much increase, this is written here. Then slight increase, and then fluctuate means sometime increase, sometime decrease. After that, the Third one, decrease. There is a rapid decrease and it went to the zero up to this one. So this is how the graph is described. You can use the values by the year. You can also give the general opinion that from this year to this year increasing. But if you put the numbers, so you can get more marks. Got it?
Yes.
Okay. After that, the question, they're saying suggest the reason for change in production of CFCs after 1987. They're saying what happens the production after 1987. Where is 1987? You can see somewhere here. After that, what the graph is showing, it is decrease or increase?
Decreases.
Decreases. What can be the reason of this decrease? You know the chlorofluorocarbon, how they produce. It is produced by these perfumes. It is produced by refrigerators. It is produced by air conditioners, the air condition, the ACs, and also when this uh, the pollution, I mean this smoke which is coming from fossil fuel is going up to the atmosphere, then the chlorofluorocarbon produced. So it means that if there is a decrease in chlorofluorocarbon, so there is a decrease in the use of ACs, there is a decrease in the use of refrigerator, there is a decrease in the use of perfumes and these sprays, and maybe the burning of fossil fuels. All these the reasons. Got it?
Yes.
So there is suggest a reason for change in production in after 1970. It means 97 means it is decrease. And what can they use? That international ban, maybe they made a policy or they make a, you can say, rules that the ACs cannot be used, that only they can be used up to this time. Maybe they will make the law that there is a ban on these things for 1 year, and maybe they use some alternatives. Okay, they use some alternative instead of CFCs. They are using HCFCs and this one HFCS, that is hydrofluorocarbons, and this is chlorofluorocarbon. So maybe instead of this one they use this one. Maybe economic downturn, maybe that country become poor or due to any reason, or maybe there is a problem of electricity, so all these devices are not working, or they educate the people that less use of CFCs. So all these the reasons can be the decline in the production of the CFCs. Got it?
Yes.
Okay. After that, CFCs are greenhouse gases. Name two other greenhouse gases. So you know the chlorofluorocarbon, they are the greenhouse gases, but name other two. So there are a lot. Please keep in your mind, and in the exam, if the question comes, so you can write any one of them, two of them, depending. Carbon dioxide, carbon monoxide, methane, nitrous oxide, water vapors, ozone, hydrofluorocarbons, here written. Then you have perfluorocarbons, sulfur hexafluoride. All these are written. So you can give any two or any three depending on the how many marks or how many they are asking for. After that, explain how greenhouse gases cause the greenhouse effect. This thing, as I told you before, that you have to write in a sentence form. So they are saying that short wave radiation, light energy from the sun, it is reaches to the earth. For example, this is your earth, this is sun. So here the radiation come from the sun to the earth. Long wave radiation or heat reflect from the earth's surface. So they goes back after earth, again they goes back. Long wave radiation, but if there is a greenhouse gases around the earth, so they will trap it. Instead of it will go out, they will stop it on the earth. So this long wave radiation, they cannot go out of the earth or the atmosphere. So what happens, the temperature of the atmosphere or temperature of the earth start to increase, and that is known as global warming. The temperature, every temperature of the earth is increasing, understand, and due to that, the every year the temperature is increasing, and that is causing the global warming. Got it?
Yes.
Okay, now next question. There is a graph shows carbon dioxide concentration in the atmosphere from 1960 to 2015. So it is telling that how much concentration of carbon dioxide is present in the atmosphere. So if you see the graph, so you can find here that on this side, this is the graph, and parts per million. Okay, it's written, maybe you sometime you notice even on the medicines, even on the water bottles, written like this: ppm. P for parts, this for per, and this for million. ppm, parts per million. It means that, for example, if it is a 310, it means that if you have 1 million particles, from that 1 million, 310 will be carbon dioxide particles. So this is how they wrote that parts per million. So in 2000, in 1960, let's say the concentration of the carbon dioxide in the atmosphere was almost 315 parts per million. What does it mean? If you will take 1 million particles of what? Atmosphere. If you take the 1 million particles of atmosphere, from that 1 million, 310 is carbon dioxide and other are other things. So this is what they are meaning of these things. Understand the concept or not?
Yes.
Okay. On this side they are telling the years, and you can see once again here it is a little bit fluctuation, increasing, decreasing, but generally there is a increase of concentration of carbon dioxide in the atmosphere with the passage of time, because this graph line is going up. So this is the first thing. Now see the question. Now we'll go for the question. Describe the trend in carbon dioxide concentration in the atmosphere between 1960 and 2015. As you can see, it is a generally it is a increasing. So what's the answer? Steadily or slowly increasing, or there is a rise. After that, they're saying calculate the change in carbon dioxide concentration in the atmosphere between 1960 and 2015. How much there is a change? So that is really simple. So you will see in 1960 how much. So here they are showing that according to this was 316 in the 1960, and if you go in last one, so how much it will be 2015, you can see here it will be 2000, sorry, 402, 2, 4, 6, 8, 10. So this 2002, 4002. Okay, so here they have given here 4001, because it is, yes, in between. You can see here it is not, it is in between half. So if you will enlarge it, you can see it more clearly. You can see it is not in the up. So it is 2000, 4,401. So you have the first value and you have the last value. First value is what? 316. last value is 400, and then you will minus them, so 85. So that is the difference between how much it's increased from 1960 to 2015. Got it?
Yes.
Okay. After that, they're saying explain the trend in carbon dioxide concentration in the atmosphere between 1960. What is the trend? What is happening? So here, as we discussed, that increase, why it happened like this? Because of lot of things. Because carbon dioxide produced by what? Burning fossil fuel, vehicles, industry, burning of natural gas, decrease of the forest or deforestation, increase of burning wood, all these reasons. So they are asking that why it is happening like this. Explain why it is happening, why the carbon dioxide value is increasing. So you can say that increase in the burning of fossil fuels. Okay, you can say more industry, because with the passage of time, more industries came, more vehicles, more than the burning of coal, natural gas, deforestation, increase of wood. All these are the reasons the increase of carbon dioxide production. Got it?
Yes.
Okay. After that, they're saying state two ways of reducing carbon dioxide emission. So very simple, use of alternative renewable energy resources where you cannot produce carbon dioxide. You can use biomass, you can use hydroelectric, tidal wave, solar, geothermal. Instead of using cars, people should walk, public transport they should use, international, their agreement laws should be there so they can reduce the production of carbon dioxide. Or you can use the devices which are more energy efficient. Okay, instead of diesel cars, they should use hybrid cars. Domestic examples, use of you can say limiting. Domestic means you will use the less energy at home. Laws, you can make the laws for emission of the factories, they can put the scrubbers. Remember we talk about in the chimneys they put like scrubbers and they will stop the harmful thing. So all these are the ways by which you can reduce the carbon dioxide emission. And one also, the increase the forest, increase the trees, that can also be there. Got it?
Yes.
Okay. After that, they're saying there is a table shows the percentage of warming that that greenhouse gases are causing in atmosphere as a result of people's activities. So which gases here? They're saying that carbon dioxide is how much? 64%, methane is 18%, chlorofluorocarbons 14%, and nitrogen oxide they are 4%. Now you have to put in the form of a graph. Okay, so this thing is quite simple, and I think you can do it easily. Okay, and here first of all, for example, if this is given to you, this is the 0, then 10, 20, 30, 40, 50, 60, then you have 70, you have 80, you have 90, and again here 100. So if this is 64, it means that you will start from here like this, and this is 50, this is 60, 64 come somewhere here. I'm just giving the example, somewhere here. So this is all 64. So but this carbon dioxide, so what you should do here for carbon dioxide, they said that you have to draw this sign, because this is the key. Okay, after that they're saying methane is 18%. Methane is 18%. Okay, now draw for methane. For methane, you can see this is 64. From here to here, there is 6 plus here 16 and 2 more here. So from here to here, it comes somewhere here. Methane. And for methane, what you have to do? You have to draw the lines. Because here. After that, you have chlorofluorocarbons. Chlorofluorocarbons, that how much they are? 14. So this is come here 82, 82 to here 8, 8 and for 6 more 96 somewhere here. And this is, and this is left, that is nitrogen. Got it?
Yes.
Okay, good. So this is there. So in the exam, it's a very easy thing. You have to just divide them into. Okay. After that, the to what extent will limiting carbon dioxide emission reduce the warming of the atmosphere? Now they're saying that what do you think if you will control the carbon dioxide emission, so it will reduce the global warming or the warming the atmosphere? Yes. Why? Because carbon dioxide is the biggest contributor. Okay, this is the first thing that can be a answer. But if you see the other way, not only carbon dioxide, there are other greenhouse gases also, like chlorofluorocarbons, like nitrogen oxide, like methane, all this one. Even you can see in this diagram, they have shown other. So from here you can see it is a big contributor. You can reduce it, but you cannot finish it because there are other gases also which cause the global warming. So you can answer that yes, because it's the biggest contributor, you can reduce it, but you cannot completely finish it because there are other gases also which causes the greenhouse effect. Got it?
Yes.
Okay. Move to the next question. Okay. Now here they are talking about the Earth, and diagram shows the atmosphere around the Earth. This is your Earth and this is the atmosphere. So they have given here A, B, C, D, E. Got it? So here they're saying complete the table using letters A to E from the diagram. I will try to reduce this little bit more so it can come on a one page. See here. First one, ozone layer. Where is the ozone layer? Here, this one. And how do you know this is a ozone layer? From here you can see it is stopping here, sun rays coming here, going back here, all this one. So from here you can say there is some layer which is stopping them, that is the ozone layer. So that is A. Stratosphere. Where is the stratosphere? Stratosphere comes above the ozone layer. After that you have troposphere. That troposphere is the first one here. Then B is what? Ultraviolet light reflected back into the space, coming from here and going back. Then E, this one E, you can see it's going straight away. And what are these? These are ultraviolet radiation and reaches to the Earth's surface. So already this is will be given to you, and you have to just label it the correct letter. For this, you have to practice the layers, the atmospheric layers and atmospheric categories. That is really important. You should know all of it. And the last class we discussed this one, and you should know that one. Go through the notes and revise them. Okay. Describe how the human activities have damaged the ozone layer. And here you see the use of chlorofluorocarbons as a coolant in refrigerator, air conditioner system. That is the one reason. Aerosol sprays, fire extinguishers, another reason. Cleaning solvent, manufacturing process, electronic components, chlorine gas, CFC release into the atmosphere, destroying the ozone. So like this, all these things, these are the human activities which are damaging the ozone layer. And I told you that ozone layer, how they damage. If you remember the last class, I told you that this chlorofluorocarbons, when they go up, so what they will do, they will divide. Chlorine become separate, fluorine become separate, carbon become separate. Then this chlorine go and react with ozone layer, and it will, what will do, it will chlorous oxide, it will produce like this, and it will damage. You can see the previous video, and I have mentioned clearly in that one, and you can check. Next, production of the chemical that caused damage to the ozone layer was banned in 1987 by an international agreement. Suggest why an international agreement is needed. Of course, that because atmosphere is not limited for one country. It's not like a land that one country has its own border. It is above the land. And if smoke is produced in one area, it can go to the other area. The pollution from one area can go to the another area. There is no national boundaries for pollution global for this one. So all the countries should make a collective decision. They should make the combined rules and which should be implemented. For example, now if only Saudi Arabia try to reduce the carbon dioxide, UAE will not do, Qatar will not do, Bahrain will not do. So then there is no use, because when this carbon dioxide go to the atmosphere, it can come over Saudi Arabia also. So for this type of the problems, you should make international agreements. So here you can see that international global problem, there is no national boundary in the atmosphere. Okay, used in many countries and travel around the world in the atmosphere. So this is the thing. Got it?
Yes.
Okay. After that, the depletion. I told you the word depletion means decrease or finish. The depletion of ozone layer is at its greatest over the Antarctic. Antarctic, Australia, and Argentina are countries close to Antarctic. They're saying that the ozone layer is badly depleted, or you can say decreased or destroyed, where over the Antarctic region. And what are the countries near that one? That's Australia and Argentina. Suggest reason why people living in Australia and Argentina are advised to keep their skin covered and wear a hat when out in the sun. So for that, why? Because ozone layer protect the ultraviolet radiation. So if there is no ozone layer, so these ultraviolet radiation come directly on the earth, which can cause skin cancer, which can cause the other things also. So here the you can say that they should put the sunblock mean the creams which can reflect that radiation, all these things. Okay, so this is the thing how it is happening, and why it is happening, because chlorofluorocarbon, they are damaging the ozone layer. Now see where the, now all the countries, they are almost producing the carbon dioxide, but the ozone hole, it is near the Argentina. and Australia. Okay. After that, atmospheric pollution may be harmful to humans. One example of atmospheric pollution is smog. And the last thing we discussed, that what is the smoke? Smoke, if you remember, I told you that if there is only water vapors in the atmosphere, that is known as fog. Fog maybe you saw in winter, and that is visibility become less. It is just like water vapor. But if fog is mixed with dust plus smoke, so then it is known as smog. So this smoke we discussed in the previous lecture, that is dangerous because it can cause a lot of things. Explain how the smoke is formed. For smoke, you need what? Fog, dust, and smoke. So for that, first of all, from where the smoke comes? Burning the fossil fuels, industry, factories, vehicles. Got it? This is the first thing. And water vapors, from where they comes? When they, due to the evaporation, they will go to the atmosphere. And when they mix together, then the atmosphere, this smoke is produced. And this smoke is produced in the special areas where there is a less air, because if the air is flowing in a high speed, so they can take the dust particle from there. But if there is no much air on that area, so dust particle remain in the atmosphere, and when the fog come, they mix with it and they make the smoke. And especially the valleys, for example, these are two mountains. This area between the mountain, this is a valley. Here the air flow is less, so mostly you find the smoke here also. So, and sometimes the temperature inversion, we discussed that. What is the temperature inversion? Temperature inversion, normally if you go up, so what happens? Temperature decreases. If you go up to the atmosphere from the ground, temperature increases. But due to the smoke and other things, there is a layer, and here temperature become more. So when you go up, instead of decreasing, temperature start to increase. So that's known as temperature inversion. For more detail, you can go to the previous lesson and that one. Suggest state two ways smoke is harmful to human health. Yes, because it causes the breathing problems, it causes the respiratory diseases, it can cause the eye irritation, lungs cancer, all these problems it can create. So you can write two, three, depending on the question they are asking. Okay. Here diagram shows the part of the structure of the atmosphere. You can see here. First one is troposphere, last one is thermosphere. What is Y? That is stratosphere, and X is the mesosphere. And again, I'm telling you, go through the notes and you should remember the arrangement or the order of the atmosphere. For example, here troposphere, this is tropopause, the top layer. Then this is what you have, stratosphere, and this is stratopause. This is mesosphere, mesopause, thermosphere, thermopause. So you should all these things, when you go to the notes, inshallah you'll understand, and you have to memorize them. The atmosphere can be polluted by vehicle emission. These emissions can cause acid rain. Explain the impact of the acid rain on the environment. This is the question. Acid rain, it can decrease the pH of the soil. It can decrease the pH of the lake. And if the soil pH decrease, no good crops. If the lake pH decrease, the fish can die. It can damage the buildings. It can damage the metal structures. A lot of things you can write for this one. Okay, here they have shown the graph shows the carbon dioxide emission per person different countries from 2015 to 2030. It's a predicted one also. So here you see, this is, they're saying 2015 in USA, it will be, the gray line is 2015 and dark gray is predicted 2030. So you can see here they have shown for different countries. So here they're saying that name three countries where the predicted carbon dioxide emission per person are lower than the carbon dioxide in 15. See here, in which countries this is predicted. Predicted where is lower, here is lower. Where it is lower, here is lower. Where it is lower? It is here is lower. So which countries? You have Germany, you have Japan, and you have USA, because this is currently less the gray, and dark gray is predicted. So here you can see the three countries. Which one? You have USA, Japan, and Germany. In 2015, the emission per person in China were 7.5 tons. In 2030, the predicted emission in China one will be 8.3. Calculate the predicted percentage increase. So it's quite simple, like mathematics you are doing. So this is predicted, this is current. Minus them, this is the increase. So what you will do, the current one. So change, divide by current one, multiply 100. So this is the 10.6%. It is the percentage increase. Got it?
Yes.
Okay, so these the question are like this. So I'm sending you these notes so you can just go through them. And if you have anything, so you can ask in the next class. Okay.
Okay.
Okay, thank you very much. See you inshallah next class.
Okay. See you.